Welcome to our WARPjet presentation. WARPjet Technology stands for Wireless Access Routing Protocols for Jet Speed Broadband Connections. WARPjet breaks the internet speed limit and provides the bandwidth necessary for true, on-demand, full 1080p HD quality movies without transmission delays. WARPjet can support multiple simultaneous HD video streams, including 3D HD. WARPjet's capabilities will help open up the IPTV broadcast market. WARPjet works by creating an ad hoc wireless network among other WARPjet-compatible devices, then aggregates the available internet bandwidth of several devices together and delivers this aggregate bandwidth to any user on an as-needed temporary basis. Here we have a WARPjet development unit. The primary data connections to the device are the RJ45 jack that goes to the local computer, Wi-Fi adapter, and the internet connection. The unit also has a couple special feature interfaces for development purposes only. The production unit will look exactly like any other typical wireless access point that's on the market today, with 4 Ethernet ports, a broadband port, and 1 or more antennas. In fact, WARPjet technology can be incorporated into many existing wireless access points through a software upgrade. However, greater flexibility and speed can be achieved when the technology is incorporated into the actual chipsets for the new wireless access points, computers, game controllers, and mobile devices. While today we are demonstrating the WARPjet using Wi-Fi connectivity, the technology is equally well suited to any other wireless technology such as WiMAX, LTE, and 3G connections, or combinations of several wireless technologies such as Wi-Fi and WiMAX, as shown in our presentation, in which case we would have the 2 radios in the unit instead of this one single Wi-Fi. Here we show a typical installation with a WARPjet compatible router that has a 5 megabit DSL internet connection. During normal use, the WARPjet router operates exactly like any standard wireless router. That is, the attached internet connection is used solely for the benefit of the local network or computer. Here we show a typical neighborhood with every household having their own dedicated internet connection and router. And for typical web browsing and email functions, this is a satisfactory model. But once a user wants to perform some function such as downloading a huge file such as an OS upgrade or a large HD movie, which can easily exceed 5 gigabytes, this model fails miserably, and this is where WARPjet technology comes into play. For this demonstration, we show the local computer connected to the WARPjet router through the Ethernet cable, but it can just as well be connected through the Wi-Fi connection, just as any existing wireless router works today. Once the user attempts to download a huge file, the WARPjet router will automatically contact 1 or more other WARPjet compatible devices and solicit their help to download the file quickly. In this demonstration, we have another WARPjet router, which represents a neighbor's router with its own internet connection, as shown here. In this demo, the second router has a 5 megabit internet connection as well. So once the initiating WARPjet router begins the download, it contacts the other remote WARPjet routers and asks for their help to download the file. All of the participating WARPjet devices create a temporary ad hoc wireless network that is then used to transfer packets of the HD movie that they have received through their own internet connections via multi-link download. Here we show a WARPjet network consisting of 3 participating remote devices, which provides an aggregate throughput of 13.5 megabits. When we need greater bandwidth or for higher resolution video, WARPjet automatically creates and optimizes the ad hoc network depending upon many factors. Here, WARPjet has created a network with 2 connections being hopped from remote devices which are not in direct radio range of the initiating device. Such a network can be capable of extending connectivity to great distances in order to develop greater download speeds. The configuration shown here portrays a network capable of downloading the file at 44 megabits per second. In this figure, we show a network where the WARPjet router has both Wi-Fi and WiMAX connectivity. This arrangement provides the high speed of Wi-Fi and the long-range connectivity of WiMAX. WARPjet can aggregate any type or number of wired or wireless connections. The actual transfer speeds that WARPjet is capable of obtaining is only limited by the type and quantity of wireless transceivers built into the WARPjet device. Today we can bond two Wi-Fi channels together for a total aggregate of 108 megabits. Adding a WiMAX or an LTE interface will provide additional range as well as greater speeds. So back to this demo. We have the initiating WARPjet device, which has started the download through its own internet connection that has a transfer rate of 5 megabits per second through its internet service provider. We also have an additional 5 megabit data transfer across the Wi-Fi interface between the initiating device and the remote device, which would normally be located some other location. This 5 megabits of data is coming through the remote WARPjet's internet connection via its internet service provider, which may or may not be the same provider as that of the originating WARPjet device. So now this Ethernet cable has an aggregate bandwidth of both internet connections for a total of 10 megabits effective transfer rate. Once the transfer is complete, the initiating WARPjet device will tear down the ad hoc network and all the remote devices will return to their normal operation. With a WARPjet network capable of transferring data at a rate of 100 megabits a second, an HD movie of 3 gigabyte size could be downloaded in less than 5 minutes and can be viewed immediately while it is being downloaded. Here's an example of a typical residential WARPjet ad hoc network. Don't let the seeming complexity confuse you. This figure simply shows the possibilities of routing paths that WARPjet can use to configure its ad hoc wireless network in order to download huge files. It also shows how our WARPjet technology can be implemented in any internet-ready device, such as a TV or set-top box, game controllers, routers, computers, cell phones, or any other internet-ready device. Figure 6 shows how WARPjet technology can be implemented in a cellular network. Here we show the existing cellular data paradigm, with every cell phone having a separate data connection to the cell tower. In this example, each cell phone is receiving a separate data stream of the same content or live media event. This uses much of the cell tower's channel capacity as well as much backbone capacity to carry the same data to each phone. However, using WARPjet-enabled cell phones, cellular operators can reduce the cellular network loading by sending the media to only a few cell phones in the general area of the cell tower and having the cell phones relay the media to other phones in the general area using alternate cell channels or Wi-Fi, Bluetooth, WiMAX, LTE, or any other wireless link. Here we show the internal hardware for one of our WARPjet development units. The unit consists of our main development board running a Linux kernel and our WARPjet software. Here we have our Wi-Fi transceiver for our wireless connectivity. Again, this could just as easily be a WiMAX or LTE interface or any other wireless technology that is suitable for custom implementations. And here we have our 4-port Ethernet switch. Typically the 485 jacks for this switch would be available on the outside of the WARPjet router, just as they are on any commercial wireless router that you would purchase today. Of course, we have our power supply, and for developmental and legacy purposes, we have a modem as only part of the development system and is not part of the commercial product. So there you have it. Thank you for watching our WARPjet demonstration. WARPjet, breaking the internet speed limit for you.